In the last classes, we were discussing about how can we evaluate an information retrieval system. In that two techniques, micro evaluation and macro evaluation. Micro evaluation in general is dealing with an evaluation depends upon some specific point of view. That is, it depends upon some specific parameters. But macro evaluation is a general one. It doesn't depend upon any of the parameter. And we finished a discussion about micro evaluation method. In micro evaluation, we are using averaging method. So another alternative approach to averaging is macro evaluation, which can be independent of any parameter. This parameter may be coordination level or relevance score, like that. In averaging, what we do is we'll be obtaining a set of standard recall values for which average precision values are calculated by averaging over all the queries the individual precision values corresponding to the standard recall values. But quite often, no unique precision value corresponds to exactly some recall values. So it becomes necessary to interpolate. Here comes the importance of the method interpolation. Interpolation is a statistical method by which related known values are used to estimate unknown values. By using interpolation, we can create unknown values from known values. For example, if you take the case of a line, we will be having a starting point and an ending point. We can find the intermediate points between these 2 points by using the method interpolation. That is its main idea. So in this figure, in the left we can see some points A, B, C, D. These are our observation points or observed points. These two figures are typical PR graph figure. We all know that what is a PR graph? Precision recall graph. This PR graph is mainly used for measuring or graphically representing the performance characteristics of an information retrieval system. Here in the y-axis we will be having precision, and in the x-axis we are having recall values. Here the points A, B and C, A, B, C and D are called the observation points because these are the only points observed directly during an experiment. Then the in-between values, that is what may be the value of recalls in between A and B. All those values should be calculated from the method interpolation. So we need to infer those values from the existing observed values. So if you take the case of this point A, we are having R1 and R2 that has been observed. Then the next point B is the one corresponding to an increase in recall. We can experience an increase in recall, which follows from a unit increase in the number of relevant documents retrieved. We all know that how can we increase a recall value? The number of relevant documents should be increased. Like that, in this observation, the recall values increased. That means in the second observation, the relevant documents, the number of relevant documents is increased. Here in interpolation, what we do is we will be supposing between any two observed points, the recall remains constant since no more relevant documents are retrieved. That is, we can do that. Here what we do is in between two observations, the number of retrieved documents or the number of relevant documents remains the same. So we can say that the recall is same in between A and B. That is why we put a line in the right hand figure in between R1 and R2 up to B. So from A to B, what we do is we will be using the same R2. That particular process is called interpolation. So here the right hand picture is the interpolation output of the left hand picture. Interpolation means what? We will be trying to find out the unknown values between two observations. That is, here what we do is here we found the unknown values from the origin to R1, then from R1 to R2, then from R2 to R3, and then from R3 to R4. So we calculated those intermediate values. That is the horizontal line. So here the values are the same. Okay. Hope it's clear. And the point R lambda P lambda be the set of precision recall values obtained by varying some parameter lambda. Here lambda is our observation, that will be from 1 to 4. Here there are 4 observations. To obtain the set of observed points, we specify a subset of the parameter lambda. 1, 2, 3, 4 like that. Thus, r theta p theta, it is an observed point if theta corresponds to a value of lambda at which an increase in recall is produced. We now have a set. Here the GS corresponds to, or GS represents a set which contains an ordered pair r theta s and p theta s. This is a set of observed points for a request. To interpolate between any 2 points, that is, here we are trying to find out the values in between any 2 observed points. We can define that as Ps of r equal to supremum of P, where r dash should be greater than or equal to r, such that r dash comma P should be an element of this set GS. Here the SUP, sup means supremum, that is the local maxima. Then ST means such that. So here what we do is, here we are trying to interpolate the values in between 2 observations. Here R is the standard recall value. From this we can obtain the average precision value. So by using the interpolation technique, we can find the intermediate precision value. We can find the intermediate recall value. Here the average, obtain the here the average precision value is, it can be given by the equation PR equal to sigma S element of S PS of R divided by number of observations. Here the S means number of observations. Hope it is clear. So in between value, here you can see in that picture there is a line. That means we will be taking same value in between these observations. This is a representation of this interpolated precision. You can see in the left hand picture we are having precision and recall graph. If locally precision increases with increase in recall, then you should get to count that. We may take the advantage of this interpolation technique in order to generalize this graph. From this graph we can understand that generally, not specifically you can see some spike, then there is another dip, then there is another increment. But in generally we can understand that upon increasing the recall, the precision is also somewhat increasing. It is in the increasing mode. So generally we need to get that idea. That's why we are using this interpolation. In interpolation, that is the right hand picture, you can see some proportional change. That proportional change only we need to get from this particular evaluation. That's why we are using interpolation technique. That's why we are using the macro evaluation. Here you can see this is the blue thing is our average PR curve. Then that red thing is our interpolated curve. So from the interpolation, we will be getting some generalized idea about this PR curve. That generalization is what we need. That generalization is our macro evaluation. Hope it is clear. Now we need to discuss about Swets model. In this last classes, we were discussing about some information retrieval evaluation models. In early 90s, in 1963, there is a guy called Swets, and he expressed his dissatisfaction with existing methods of measuring retrieval effectiveness. He is not at all happy with the existing methods of evaluating this information retrieval system. So, he himself formulated an evaluation method based on statistical decision theory. And it was interesting that the Swets model is theoretically attractive and links information retrieval measurements to a ready-made and well-developed statistical theory, but unluckily, it has not found general acceptance amongst workers in the field. In this information retrieval field, this model was not at all an acceptable one. But again, we need to discuss about this thing. In this model, there are some properties. That is, in his mind, he thought that for an information retrieval system, evaluation system, for an IR evaluation system, some properties should be there. These are the properties that was in his mind. The first property is it should be solely based on the ability of the information retrieval system to distinguish between wanted and unwanted items. That means relevant and irrelevant items. This evaluation should be based on that power of distinction of a particular IR system. Then an IR system should express discrimination power independent of any acceptance criterion employed by a system or user. That system should be completely independent of any acceptance criterion employed by a system or a user. Then that measurement should be a single number, and it should allow complete ordering of different performances, indicating the amount of difference and assess performance in absolute terms. Any performance measures are there that should be ordered. That is, that evaluation system should have the capability to order those performance metrics. And Swets characterizes recall fallout curves generated by the variation of a control variable lambda. Here lambda means coordination level or a relevant score. And he made use of recall fallout curves. Till now we were discussing about the precision recall curves, but Swets accepted recall fallout curves. Assume this lambda, that is our coordination level or the relevant score, it is distributed normally on a set of relevant and non-relevant documents. That is our assumption. And he defined some basic variables. That is, we all know that what may be the meaning of this precision, then recall and fallout in probabilistic terms. Recall, what we know is, it is the measure of what? The number of relevant documents. So recall is an estimate of conditional probability that an item will be retrieved given that it is relevant. We can denote it as probability of B given A. So he defined all these variables in terms of probability. Hope it is clear. And next one is the precision. Precision can be defined as it is an estimate of the conditional probability that an item will be relevant given that it is retrieved. So precision is always depends upon what? The number of retrieved documents. Recall is something related to number of relevant documents. Now we need to discuss about fallout. It is an estimate of the conditional probability that an item will be retrieved given that it is non-relevant. It can be denoted by using probability of B given A bar. So for the Swets model, we'll be interested in probability of B given A and probability of B given A bar. That is, here he considered the precision fallout curve. Recall fallout curve. Hope it is clear. In that way, that is up to this particular model, we were having two curves in order to visualize the performance characteristics of an information retrieval system. That two curves were precision recall, that we discussed about that, precision in the y-axis and recall in the x-axis. But Swets accepted the recall fallout for this purpose. He accepted these two curves, that is, he accepted precision recall curve and recall fallout curve in order to represent the performance characteristics of an information retrieval system. But again, he rejects precision recall curve and he accepted this recall fallout. He selected recall fallout curve for representing the characteristics of an information retrieval system. So in the simplest case, we assume that variable lambda is distributed normally on the set of relevant and non-relevant documents that we discussed that. Here the lambda means the coordination level or the relevant score. It is distributed normally along relevant and irrelevant documents like this picture. Here the first distribution is for irrelevant documents and second distribution is for relevant documents. So we only require the right distribution curve. That's why it is shaded. That shaded portion that only we need to retrieve. But here you can see from lambda c we will be retrieving the documents. There are some common area. So that from the common area we need to remove something. That removal is our irrelevant documents because the first distribution corresponds to what? Our irrelevant documents. Right distribution is the relevant documents. So there is one common area. So we need to remove that common area from irrelevant documents. Those documents are our fallout documents. That's why he selected the recall fallout curve for representing the performance characteristics of an information retrieval system. So he measured the effectiveness of a retrieval strategy by measuring some appropriate variables. That is, till then the performance of an information retrieval system was found by calculating some appropriate variables like recall, precision and fallout. So it depends upon the calculation or the amount of these variables. Hope it is clear. But Swets model only accepted what? Recall and fallout, these two values. So it is confined to these 2 points. So in order to get the correct performance values or effectiveness, what Swets done was, he tried to get the operating characteristic curve or OC curve of this particular distribution. It will be like this. This is the OC curve. Here the two OCs are there, ST and UV. These are the two operational operating characteristics curve of recall and fallout. Here you can see P of B given A bar, that represents the fallout, probability of B given A, that represents the recall. So there are two operational characteristics here, UV and ST. In order to find the effectiveness of this system, we only need to find the distance of this UV from origin, or distance of ST from origin. Then you can find that effectiveness. This is the operating curve for a particular point, F lambda, R lambda. For a fallout and a recall, the Swet has implemented this OC curve. Here two OCs are there, UV and ST. You can see one line from the origin O. We need to find that distance from O to UV or ST in order to find the effectiveness. Swets used this OI, that means the distance from the origin to UV, as the measure of effectiveness. That is the main point. Swets used the distance of UV from origin in order to find the effectiveness of this particular system. And we can prove that particular distance is mu2. Here you can see mu2 minus mu1 divided by half sigma 1 plus sigma 2. Here we all know that mu means what? The mean of the distribution. Mu2 is mean of the second distribution. Mu1 mean of the first distribution. Then sigma 1 is the standard deviation of the first distribution. Sigma 2 is the standard deviation of the second distribution. So here what we do is, here we are simply taking the difference between the means of the distribution, then normalized by the average standard deviation. Here we are in the denominator, we will be taking the average of the standard deviation of two distributions. That is, in that picture we saw two normal distributions for relevant and irrelevant documents. Here in the denominator we will be taking the average standard deviation, and in the numerator we will be taking the difference between the means of distribution. Hope it is clear. Mu means mean and sigma means the standard deviation. And there is one guy whose name is Brooks. Brooks modified this equation. Brooks modified this equation as S2 equal to mu2 plus mu1. He took the summation of mu2 and mu1, and in the denominator he took sigma 1 square plus sigma 2 square whole raised to half. That means root of sigma 1 square plus sigma 2 square. That is sigma square. What we meant by that? That is the variance of our distribution. Sigma is the standard deviation and sigma square is the variance. So the updation, Brooks, it is another guy, he modified the Swets equation as mu2 plus mu1 divided by sigma 1 square plus sigma 2 square, the whole raised, sigma 1 square plus sigma 2 square raised to half. That is root of sigma 1 square plus sigma 2 square. Instead of standard deviation, Brooks is taking or considering the variance of the distribution. So with this, we will be finishing our third module. From the next classes, we will be starting our fourth module.